Good afternoon. Myself Dr. M. Kumar. Today I am going to discuss about the transducer. So the transducer is a device which converts the physical quantity into a proportional electrical signal is called the transducer. So the electrical signal is produced maybe a voltage, current or frequency. The process of transmitting signal from one to another is called the transduction. So the transducer is also called as a pickup. So actually the electric transducer consists of two parts or sensing or detecting element and transduction element. The sensing or detecting element is commonly known as a sensor. So the definition states that the sensor is a device that produces a measurable response to a change in physical condition. So the diagram it's clearly so the transducer element. So the non-electrical quantity is given as an input to the sensing element. After sensing the non-electrical quantity, it sends the response and to given to the transduction element. That is a electrical signal. So it is a common range in the electrical signal used to represent the analog signal in the industrial environment like 0 to 5 volt or 4 to 20 milliamps. For the industrial applications, nowadays the 4 to 20 amps range is most commonly used to represent the analog signal. A current is a 4 amps represents the zero output and current as a 20 milliamps represents the full scale value. In case of the voltage is a 5. So the many time the transistor is a part of circuit and works with the another elements in a circuit to produces the record output. Such a circuit is called the signal conditioning circuit. So the advantages of the transducer. So the electrical signal can be easily attenuated or amplified. The power requirement of the transducer is very small. The output of the transducer can be easily used, transmitted and processed for the further purpose of measurement. Reduces the effect of the friction and other mechanical non-linearities, and also integrated circuit technology and for the system compact and having the less weight and portable. There is no mechanical wear and tear and reduce the effect of mass inertia problem. So even though we have so many advantages, but disadvantages also having. The disadvantages is a cost. So the design in the circuit is a effect of aging and other parameters actively to reduce the performance of the the transducer. And also the electric transducer must have the parameters, that is the um, parameters like what are the things used to be happen in the transducer, that is a linearity, sensitivity, dynamic range, repeatability. The characteristics of the transducer is accuracy, then ruggedness, linearity, repeatability, then high output. So these are all the some of the characteristics of the transducer, then followed by the high stability or reliability, sensitivity, dynamic range and size and speed. So how we are going to selecting a transducer? By using an operating range and also the sensitivity, the frequency, environmental compatibility, and the minimum sensitivity, accuracy, usage of ruggedness. Then the classification of transducer. So in general, electrical transducer are classified according to their structures, application area, method of the energy conservation, the output signal, etc. So the classification is mainly as a active and passive transducer on the basic of transduction principle used on analog and digital transducer, primary and secondary transducer, and as a transducer and inverse transducer. So these are all the classification of the transducer. So the classification is mainly on the active transducer or self-generating type of transducer. So the active transducer is a photovoltaic, thermoelectric, then piezoelectric and electromagnetic. So the passive transducers are the variable resistor, optoelectronic and variable reactance. So the variable resistance again classified into photoconductor, strain gauge, thermistor. Then optoelectronics also again classified into photoemissive and photojunction. Then inductive is classified again into four types: variable reluctance, variable permeability, LVDT, then eddy current. So the again the variable classification capacitance, the capacitance having the variable area, variable separation, variable permittivity. So these are all the some of the classification of the transducer. So according to the principle and parameter to be measured, we are categorized into the various transducer. Thank you.